Assalamualaikum warahmatullahi wabarakatuh. My name is Fadin Zahira. In this video, me and my teammates, Muhammad Izzat and Nur Amira Balkis, will talk about our topics from science to smartphone, the journey of class in electronics.
Smartphones have become an essential part of our daily life. We use them for communication, entertainment, and studying. However, many people do not realize that the main material used to produce smartphone originally comes from something very simple, sand. This presentation will explain how sand is transformed into the advanced technology that fits in the palm of our hand. This presentation focuses on the transformation of sand into key materials used in smartphone. Sand, which contains silicon dioxide, is processed into glass for display screens and silicon for semiconductor component. These materials play a crucial role in enabling modern smartphone technology. This slide shows the background history of silicon development in electronics. In 1915 to 1916, Jan Kowalski discovered a method to grow single crystal. This method later became very important for producing high-purity silicon used in electronic devices. In 1947, the first transistor was invented at Bell Laboratories. This invention marked the beginning of modern electronics and replaced bulky vacuum tubes with smaller and more efficient components. In 1954, the first silicon transistor was developed. Compared to earlier materials, silicon provides better stability and wider availability, making it more suitable for large-scale production. Between 1955 and 1960, the Kowalski process was improved further. This allowed the mass production of high-purity silicon wafers, which became the foundation for microchips and modern electronic devices, including smartphones. In 1965, Moore's law was introduced. It predicted the rapid growth of transistor density on silicon chips, which guided the development of the semiconductor industry for many years. In 1971, Intel released the first commercial microprocessor. This demonstrated the power and potential of silicon-based technology in computing devices. Between 1990 and 2000, early smartphones and feature phones began to appear. These devices rely on advanced silicon microchips to perform communication and basic computer functions. From 2010 to the present, smartphone technology had advanced significantly. Modern smartphones now contain billions of transistors made from highly refined sand-derived silicon, allowing faster processing, better efficiency, and increased functionality.
In modern electronics, glass is not just a protective material, it plays an active role in device performance. I will focus on two main applications of glass in electronics: display technology and its function electronics component and isolation. The first application of glass is in display technology, especially in smartphones and tablets. Glass is used because it's highly transparent and allowing clear image display, and is also resistant to stretch. In addition, glass supports capacitive touch technology, which enable accurate touch detection when we use our finger on the screen. Besides displays, glass is also widely used in substrate in electronic components. It acts as electrical insulator, preventing unwanted current flow that could damage circuits. Glass is commonly found in sensor and camera modules, where stability and insulation are very important for device accuracy and safety. A well-known example of glass used in smartphone is Gorilla Glass, developed by Corning. This type of glass is chemically strengthened, making it more resistant to strike and impact. Because of its durability, Gorilla Glass is widely used in smartphone screen to protect device from daily wear and tear. Another example is touchscreen glass, which is usually made from aluminum silicate and template glass. This glass is designed to be both durable and sensitive to touch. It allows users to interact smoothly with their device while maintaining protection for the internal electronic components. Now we are going to advance and innovation. One major advancement in glass technology is the development of flexible glass. This ultra-thin glass can be bent without breaking and is used for foldable smartphone. Despite being flexible, it still maintains strength and high transparency, making it suitable for next generation electronic devices. Looking into the future, glass technology continues to evolve. Researchers are developing smart glass with embedded sensor, as well as self-healing and energy-sufficient glass. These innovations have the potential to further improve the durability, functionality, and sustainability of electronic devices. Zahira, does the glass has benefit and advantages?
Yes, Izzat, glass also has its own benefits and also advantages in smartphones. I'm going to talk about advantages of glass in smartphones first. The first one is support capacitive touch sensitivity, which is essential in modern touchscreen operation in smartphones nowadays. The second one is heat dissipation. Glass helps improve phones' thermal performance and prevents overheating. The third one is glass is also scratch and impact resistant, which is very good for a smartphone as it protects screen from daily wear and also damage. Now, I will be talking about the benefits of using glass in smartphone. First, better wireless charging. So consumers can get a faster charge without plugging in the device to a traditional charger. The second one is design flexibility, which is glass easier to mold and shape than metal. So it offers a greater flexibility for manufacturers to experiment with different designs and also form factors. The third one is using glass can improve reception. As glass is radio frequency transparent, it allows the embedded antennas to maintain stronger connections and faster data transmission. The future trends. I'm going to start first with eco-friendly manufacturing. It can be done by adoption of sustainable materials and processes to reduce carbon footprint. Next, silicon chip improvement. By doing the improvement, we can help reducing power consumption and also boosting processing speed in the smartphones. Last one and also the third one, oleophobic and anti-reflective coatings, enhancing user experience by reducing fingerprints and glare on the screen at the smartphones. I'm going to pass now to Amira to talk about the challenges in the journey.
Next, we move on to the challenge in the journey. One major challenge in silicon technology is silicon purification. The production of ultra-high purity silicon, up to 99.9999%, requires very high temperature and consumes a large amount of energy. Another challenge is crystal growth defect. During the crystal growth process, defects such as dislocation and oxygen impurities can occur. This defect reduces wafer quality and lower production yield. Finally, there are environmental and cost pressures. Semiconductor manufacturing produces high emission and hazardous waste, and the construction of fabrication plants is extremely costly. These factors create both economic and environmental challenge for the industry.
As a conclusion, the journey from sand to smartphone shows how a simple natural materials like sand can change into an advanced technology. By refining silicon and using glass in displays and electronic parts, smartphones can become powerful, durable, and also user-friendly. Although the process comes with a high cost and environmental challenges, ongoing improvements in materials and manufacturing are leading to better performance and sustainability.